Start working through these problems on your own paper. When you do so, remember that in order to multiply these together, we're going to multiply everything in the first parentheses by everything in the second parentheses. So for our first problem here, for number 1, we're going to do x times x, which gives us x squared. Then we do x times a negative 4, so that's going to be minus 4x. Then we have 3 times x, so that's going to be a positive 3x, so plus 3x. And 3 times negative 4 is negative 12. Having done that multiplication, then go ahead and combine the like terms. Now, in terms of this particular problem, we have the negative 4x and we have our 3x. So we can go ahead and combine those. So negative 4 plus 3 is negative 1. So it ends up being x squared minus x minus 12. Again, do number 2 and then follow along as we do it here. So first up on this one, I'm going to want to multiply the parentheses together. Oftentimes the question comes up, should I multiply the 2 in first? Well, you technically can, but if you do so, you're only going to be multiplying it into one parenthesis. Sometimes people are tempted to multiply it into both sets of parentheses, but what you've done is you just multiplied it by 2 twice. So we don't want to do that. And so as a way to keep it from becoming a potential issue, I always suggest multiplying the parentheses first, and then you don't have to worry about that. And so when you do so, then that 2 just stays out front, and then we're going to do the x times x times negative 6, negative 5 times x, and then negative 5 times negative 6. And then go ahead and combine those like terms. And once you've done that, you can now go ahead and multiply the 2 in. Remember, the 2 gets distributed to all 3 terms. This then should give you this answer of 2x squared minus 22x plus 60. All right, and finally now on to number 3. Like the previous ones, do it on your own first, and then follow along as we do it here. So like number 2, I'm going to start by multiplying the parentheses together. That means the x that's sitting out front is just going to stay sitting out front. And then I'm going to multiply the x times x, the x times the 9, the negative 2 times the x, and the negative 2 times 9. Go ahead and combine the like terms. And then once you've done that part, you can now go ahead and distribute the x into both of those terms, or all 3 of those terms actually. So we're going to do x times x squared. When we multiply x's, we add their exponents. We can multiply them when they have different exponents like this. It's adding that we cannot do when they have different exponents. So if I do x times x squared, that's going to give me then x cubed. And then we do x times 7x, so that's going to give me 7, and then x times x is x squared. And then finally we do the x times the minus 18, which gives me minus 18x. Our goal in this lesson is now to take the work that we just did with expanding the polynomials and now take it the other direction into factoring. Factoring, remember, is just like what we did except backwards. So we're going to be introducing parentheses into each of these problems. Again, write each one down on your own paper and work them out as far as you can before we actually go through them together here. In the case of number 4, I'm going to factor that one by first dividing all 3 terms by some number, because when I first look at it, I notice that 24, 32, and 28 are all divisible by the same thing. In this case, 4. So I'm going to start by dividing all of them by 4. Now, since I'm dividing by 4, it's distributive property backwards, remember? So that 4 has to go outside of the parentheses. Now I divide each of them by 4. So 24 divided by 4 is 6, so it's going to be 6x squared. I'm not taking out any x's or anything, so that's not going to change the x squared. Minus 32 divided by 4 is 8, so that's going to be 8x. Plus 28 divided by 4 is 7. All right, now on to number 5. In number 5, as I take a look at this, 6, 9, and 4, there's no numbers that go into that other than 1, and of course we aren't going to factor 1 out because we could always do that. We just keep going on and on forever factoring 1 out. But you'd notice that there is an x in every single one of these terms. To be more precise, there's actually 3 x's in all of these, because I have x cubed here, x to the 4th here, and x to the 5th here. So I can divide them all by x cubed. When we do that, 6x to the 5th divided by x cubed. Of course, the 6 is going to stay a 6 because I'm not pulling any number out. Then x to the 5th divided by x cubed. When we do division, we end up subtracting the exponent. So that ends up giving me x squared. So I'm now going to take the 6x to the 5th divided by x cubed. I get 6x squared. Plus, now 9x to the 4th divided by x cubed. The 9 is going to stay the same. X to the 4th divided by x cubed. Again, we subtract the exponents. So 4 minus 3 gives me 1, so that's x to the 1, which of course is just x, so I'm going to leave that as x then. Minus, and then 4x cubed divided by x cubed leaves me with 4. The x cubes all were divided out, and so those are now no longer present in that term. Now finally on to number 6. I again need to look at it and see, okay, what can I divide out of every term? And so I start by looking at the numbers. I got 36 and 54, and so I ask myself, what can I divide both 36 and 54 by? Now there's actually quite a few different things that we can divide 36 and 54 by. As I look at them, the thing that leaps to my mind is 9. So I'm going to go ahead and pull a 9 out. But you'll notice that in this problem there's also an x in both terms. I have an x to the 4th and I have an x. And so I can just pull out another x. It can't be x squared or anything because the lowest number of x's I have is just 1, so I can only pull the 1x out. So I'm going to start by dividing both of them by 9x. So 36 divided by 9 gives me 4. X to the 4th divided by x is x cubed. Again, we're subtracting the exponents to get that x to the 3rd power. Minus stays the same. 54 divided by 9 is 6. And x divided by x is just 1, so it goes away there. So we end up with 4x cubed minus 6 inside the parentheses. But notice inside the parentheses here, the 4 and the 6, I can still divide those by something. That tells me that the 9 that I pulled out at the start was not actually the biggest number I could divide them both by. It's good to see what happens if you don't happen to grab the biggest number. So whenever you're factoring, check to make sure that the number you pulled out is the biggest by looking to see if there's anything else you can divide the inside by. In this case, I can still divide them by a 2. So I'm going to now pull another 2 outside of this. So the 9x is now going to be times 2. And now inside the parentheses, divide them by 2. So 4x cubed divided by 2 is 2x cubed. Minus 6 divided by 2 is 3. And of course, I do want to actually simplify that part that's on the outside, the 9x times 2. So that gives me 18x. And then the inside is unchanged because all I did there was simplify the part that was outside. And so I end up with a final answer of 18x times 2x cubed minus 3. Now, if you saw right away that 18 was the biggest number you could pull out, all the better, because you can actually save yourself some time and effort there in factoring it out. Having gone through those practice problems, now do these 2 problems on your own. After going through the lesson that we've gone through so far, you should be able to do these totally on your own. So, for number 7, first you look to see what can you divide them both by, or all 3 of them by. In this case, I see 5 goes into all of them. And I also see there's x's in all of them. There's actually x cubed that I can pull out of all of them. And so then now I divide all of them through by 5x cubed. So for the first one, 5 divided by 5 is just 1, and then x to the 5th divided by x cubed is x squared. Plus, then 15x to the 4th divided by 5x cubed. I do the 15 divided by 5, which is 3, and x to the 4th divided by x cubed is x, because 4 minus 3 is 1, x to the 1 is just x. Then minus 50 divided by 5 is 10, and then x cubed divided by x cubed is 1, so that goes away. You should have been able to get this on your own and get that answer totally based on the work that we had done so far. But now we have a new little wrinkle. Having gotten this far, notice inside the parentheses, that's a quadratic. And since it's a quadratic, we need to look and see, can I factor it now using that add to, multiply to kind of a method? In this case, we can. So my next step of work then, because there is going to be one more, the 5x cubed stays exactly as it was because there's nothing else I'm pulling out of every term. And then since I'm going to factor this quadratic, I'm going to end up with 2 sets of parentheses in here. So I now say what adds to 3 and multiplies to negative 10, and I should find that it's a positive 5 and a negative 2. Now go on to number 8. Again, do it first before we work it here together. All right, so for number 8, I look to see what can I divide both terms by. In this case, I see a 6 in both terms, and I see an x in both terms, so I'm going to pull out a 6x. The first term then, 6 divided by 6 is 1, x cubed divided by x is x squared. So that's all that's left in that first term. Minus, always got the minus there, then 6x divided by 6x is 1. Now, notice it's 1, not 0. So because it's 1, I still have to put that number in there. A lot of people tend to forget to put in the minus 1. Another way to remember that it has to be there, if we're going to actually factor this out, we're doing distributive property backwards. If we're doing distributive property backwards, I should be able to use distributive property and get what I started with if I multiply it in. And in this case, yes, we would get what we started with if I distribute that 6x in. I have to have the 1 there in order for there to be something to multiply to. All right, so now having done that part, I again am going to look inside my parentheses and see if there's anything else I can do. I have x squared minus 1. Now there's nothing else I can divide both of them by, but it is still factorable because it is a quadratic and it happens to be a quadratic that is also factorable. So I'm going to leave the 6x out front, and then I'm going to break the x squared minus 1 into 2 sets of parentheses by saying what multiplies to negative 1. And since the x term is gone, it's what adds to 0. So multiply to negative 1, add to 0 is 1 and negative 1. So this would be your final factored form for number 8. So you've now seen that we can factor something out of every term, including x's, and then having done so, look inside the parentheses still. If it's quadratic, factor that quadratic.